film, we have suggested that time is related to motion. Physicists now believe that the actual rate of the flow of time is related to the velocity that an object, or a space capsule, or a planet is moving through space. Since things move through space at vastly different velocities, this would suggest that time itself flows at different rates.
Indeed, this touches upon the great insight of Albert Einstein, who radically reformed our ideas of the nature of time. He showed that time is a personal perception, rather than a universal experience shared by all. That no one man's time is better than another's. We all perceive time at different rates.
Outside, and this is WWN TV News. The big story this morning is the blast-off of the Diogenes 3 space capsule. The controversial flight leaves from Edwards Space Station at noon today, despite numerous last-minute attempts to ground the experiment. Earlier this morning, we spoke with Dr. Milan Gerzig, Director of Operations for the Diogenes program.
How's it going, Dr. Gerzig?
We don't expect any problems this time. No, we don't.
What about the first two voyages?
Well, I'm sorry. I'm too busy right now to answer this question.
Diogenes 3 is about ready to undock and blast off from Edwards Space Station. We are supposed to have a direct line. Yes. Yes, there you see astronauts Chris Johnson and Lynn Wu. Our transmission is very bad. I believe that was the blast-off. This would be mission control in Edwards Space Station. The station itself is in a permanent orbit some 200 miles above the Earth, with some 50 scientists and engineers in residence. And of course, this is where Diogenes left from just moments ago.
As the world about
In about 18 hours, the spacecraft will be going 150,000 kilometers a second. Of course, most interest in the project revolves around the so-called time warp experiments, or what scientists prefer to call time dilation effects. Behind me you see one of the 3 cesium atomic clocks which will be used to measure the amount that time slows down on the spacecraft. It may sound like science fiction, but scientists say that across the face of the universe, time goes at millions of different rates as compared with time on Earth.
There are many problems in attaining velocities near the speed of light. For one thing, it takes enormous amounts of energy over long periods of time. To achieve just half the speed of light in 30 days traveling time, there would be a continual pressure of 1,000 pounds on each astronaut. And as for accelerating to, say, within 100 miles per hour of the speed of light, our astronauts would not only be old men when the speed was finally achieved, but the amount of energy consumed would be more than what is contained in our entire galaxy. So the director of the Diogenes 3 mission has conveniently invented an anti-gravity device and a superpower source, thus making it possible for the spacecraft to accelerate quickly to nearly the speed of light without pulverizing the astronauts to a fine atomic dust.
Diogenes 3 has been accelerating for 18 hours now and is doing 145,000 kilometers per second. This is Dr. Milan Gerzig, Director of Operations. Dr. Gerzig, what has happened on the flight so far?
Well, of course we're delighted that the mission is going so well. At the moment, the spatial and time distortions are very obvious.
Just what does that mean?
Yes, you will notice that...
What appears to be slow motion on a television screen is actually representing one of the phenomena predicted by Albert Einstein's relativity theory. He showed that when one system was going at an enormously high velocity relative to another, time on that system would be slower than time on the reference or stationary system. We are seeing a time dilation as it would appear on a spacecraft going about 99.9% of the speed of light.
Not at all. As far as they are concerned, everything is normal on the spacecraft. But when they hear us on their radio, our voices are speeded up, like a tape going too fast.
20 minutes ago, we began this film by suggesting that time was somehow related to movement. That's how we perceive time, through motion and change. Subsequently, we talked about clocks, and we talked about calendars. We defined a second, which is the basic unit of time in science. We talked about nanoseconds, and we talked about entropy. So, here we sit, 20 minutes later, trying to understand why the astronaut is moving so slowly. We know he is traveling very fast, at nearly the speed of light. And we know that when a body moves past us, time for it is slower than time is for us. So the astronaut crawls through his chores, his every moment stretched out. We cannot ask what he is doing now, because his now is not our now. While he is moving, he exists in a different time scheme than we do. In much the same way, every star in the sky is in a different time scheme. In physics, time means the reading of the master clock. Beyond this, we don't know what time is. But we know a few things about it, not the least of which is that we are caught, irrevocably, in its forward motion.
There's no use trying, Alice said. One can't believe impossible things. I dare say you haven't had much practice, said the Queen. When I was your age, I always did it for half an hour a day. Why, sometimes I believed as many as 6 impossible things before breakfast.